Let's do a basic Newton's second law problem here. And Newton's second law tells us that the acceleration equals the net force, or the unbalanced force acting on the object, divided by the object's mass. So in this case here, we're looking for that unbalanced force. We want to know how much force would be applied to a 1,500 kilogram Corvette in order for it to accelerate at a rate of 7.24 meters per second squared. So there's our acceleration. And the 1,500 kilograms is a unit of mass. That's our mass. And so we just want to go through the process here of using the equation for second law and solve for the net force. So we'll just go ahead and plug in 7.24 meters per second squared equals, we're still unknown, is net force, and we know the mass is 1,500 kilograms. So let's just do basic cross multiplying. Net force times 1 equals 7.24 meters per second squared times 7.24 meters per second squared times the mass, 1,500 kilograms. So my net force will just multiply the 7.24 times the 1,500, and you get 10,860 is the number, that's the magnitude. And then I need the units for this, and this is meters per second squared times kilogram. So that is the base unit for force in the metric system. It's essentially defined as the amount of force required to accelerate a 1 kilogram object to an acceleration of 1 meter per second squared. And so that gets a little bit messy looking. So in the late 1940s, the folks that are in charge of all of our units in science and everything decided to name that after Sir Isaac Newton, and so it's known as a Newton, and we symbolize it with just a capital N. And so instead of having to write 10,860 meters kilograms per second squared, we can just say that the net force required here is 10,860 newtons. So that should be our unbalanced force that we were looking for here in order to get that acceleration.